All right. So JAMStack is a set of techniques and tools that's leveraging recent advances in content delivery networks and static site generation to help you quickly, let me move this around, help you quickly move ideas out of your head and onto the web. So already that was a bit of a mouthful, right? What is a content delivery network? What is a static site generator? So fret not if you haven't heard these terms before, as they'll be the two main topics of the entire talk. We're here today to talk about how we as engineers and product managers can best design, develop, and deploy websites that are a true joy for people to use. Sorry, I had to rearrange something. So by the end of today's session, my goal is that you'll all walk away with an understanding of what problems the JAMStack was created to solve. You'll be able to use the static site generator called Gatsby to create a JAMStack blog, host it on Netlify, and maintain everything through Git. JAMStack can be used for more than just blogging, but I think that a blog will illuminate some of the JAMStack workflows quite well. And I think it's never too early for developers to get a blog going and begin learning in public. So that's what we'll build. So as I mentioned, I'm Andrew, software engineer here. Integral is a Detroit-based automotive software consultancy, and we work with clients like Ford, Bosch, Mobility, and Autonomic to help them build smarter vehicles and fleets. Right now, I work as a consultant with Ford Autonomous Vehicles, building out an iOS SDK for autonomous fleet ride-hailing. So I work on mobile now, but in the past, I've also built web platforms like a ride-hailing simulator using React and TypeScript. And I've always been super energized by client-side technology. So when I found out about the JAMStack, it really blew my mind. So I want to share what I've learned with the developer community. You can follow me on my soon-to-be outdated Twitter handle shown here or on LinkedIn, where I post nerdy things about iOS and web dev. So side note, in my free time, I also keep a blog called justkeepclicking.io, which is developed and deployed with the JAMStack techniques that we'll all learn together today. So this presentation will be one part conceptual, explaining the history and inner workings of JAMStack and its ecosystem, and one part practical with a live demo. So here's what we'll cover. First, we're going to look at the what. What is JAM? It's JavaScript, APIs, and Markdown. What's a content delivery network? After some basic definitions, we'll look at that term of CDN and why it's so important to the JAMStack. Look at the fact that static doesn't have to be boring. We'll look at the true meaning of the word static as it's used by the JAMStack. And we'll talk about why it does matter when you render. In other words, why does it matter when data enters my website? After that, we'll explore the why, performance, scaling, security, and SEO with JAMStack. We'll have a practicum, which will be the demo, where we're going to use a static site generator called Gatsby to create a blog and deploy it to Netlify using exclusively Git. And then finally, at the end, I'll share some resources and we'll have an open Q&A for everyone to just discuss what we learned. Cool, some quick housekeeping. So if you have a question during the presentation, you may have noticed they're all muted. Feel free to share it in the Zoom chat. In between the sections that I just described, like between what is JAMStack and CDN, I'll answer as many as I can, time permitting. So we'll do our best. We're going to unmute people at the end for discussion. Let me take a second here to just open up the chat so I can make sure I can see you guys. Okay, cool. All right, so let's get started. So the web development ecosystem really is an ever-flowing and ever-growing fire hose of frameworks, techniques, and tools, and it's really objectively impossible to consume it all. So how do we as engineers kind of protect ourselves against decision fatigue amidst all of these possibilities? For me, I like to follow technology trends the way that investors follow the stock market. We place bets on technology, and the currency of those bets are both our training time and the decisions that we make when building out a site's architecture. Being early to a new technology can be incredibly valuable professionally. And just like in financial markets, it's pretty hard to tell a priori who the winners in the space will be. So when I start using a tool like JAMStack, unless it's purely for my own engineering curiosity, I like to see community support for that approach. It's always reassuring to see smart developers energized by those frameworks. So doing a little bit of research, I've definitely found that JAMStack in general has been pretty well supported by both developers and industry. Some big names like Chris Collier, the guy who co-founded CodePen, and a bunch of other things, and Dan Abramov, who if you've ever been on React's GitHub for more than 2 seconds, you probably recognize the name. They're all pretty supportive of it, and that's good to see developer support for those kind of frameworks that we use, as well as industry leaders like Netlify, Nike, Little Caesars, Sequoia Capital, all kind of getting behind this new way of designing and deploying websites. So by its own definition, the JAMStack delivers fast and secure sites and apps delivered by pre-rendering files, which we'll see is half the JAMStack, and serving them directly from a content delivery network, the other half of the JAMStack, removing the requirement to manage or run web servers. So JAMStack, you may be surprised to see, is not as specific or opinionated about tooling as other stacks where the tools are in the name are, like MeanStack, Mongo Express, Angular Node, or LAMP, Linux, Apache, MySQL, and PHP, all of which are very opinionated about your tooling and even operating system. The JAMStack operates under a modus operandi of bring your own technologies. The JAMStack approach wasn't so much pioneered by, but was first formulated by the company called Netlify, a cloud company that offers hosting and serverless backend services for static websites. So if in this presentation, it feels like we're covering many disparate topics, then you're absolutely correct. That's because the JAMStack is composed of seemingly disparate things in a way that other stacks with tools in the name don't. So what does the JAM stand for? JAM stands for JavaScript, APIs, and Markdown. So I provide these definitions here for those who already have a degree of familiarity with these concepts. It may help somewhat. So please feel free to read them if they do help you. If they don't worry, because I personally didn't find these three definitions too enlightening as to what makes the JAMStack different from most other approaches to web development. I mean, practically every site uses JavaScript and APIs, right? So why even mention it in the name? I didn't get my eureka moment with JAMStack until I broke free from that kind of arbitrary ordering of topics, JAM. And funnily enough, the acronym is completely arbitrary. The Netlify founder, Matt Billman, said in a talk that they came up with the name JAMStack before even deciding what the letters even meant. They just liked the word jam. So we'll see what it really is about, which is pre-rendered files and CDN hosting. And we'll also describe what those are in just a minute. So yeah, that is most sites, is JavaScript and APIs. So for our exploration, we're going to take a little bit of a different route. We're going to start by looking at what a content delivery network is, and then we'll actually work backwards to the thing that we're deploying, which is fully static assets. And we'll do that by exploring the three main approaches for rendering websites: server-side rendering, client-side rendering, and pre-rendering. And we'll see that those two things together are what make the JAMStack unique. And then we'll bring it all together in the demo as we deploy the blog. So that's some background on the JAMStack. Our goal, deployment of awesome sites to content delivery networks. The path is JAMStack practices. All right. Let me try to open the chat one more time. Okay, not entirely sure I can see the chat while I'm sharing my screen, but we'll figure that out after this.
There aren't any questions right now.
Okay, yeah, Lindsay, when I'm between sections, I'll ask you and you can just voice the questions because I can't see them here. Okay, anyways, sorry about that. So a content delivery network, I've said it about 5,000 times now, is a service that accelerates internet content delivery. Surprise. The main benefit is that it makes your website faster. You have users all around the world, but you don't have servers all around the world. So rather than hosting all data on one or a few servers, a CDN reduces the distance between clients and servers by placing CDN endpoints like the ones here, also known as points of presence, hosting your web pages and assets in optimally placed locations. Think of it like a local asset dump for your website. Additionally, CDNs will cache responses to some logic that we give it. So not only do CDNs help speed, it also helps site reliability, as the CDN nodes are redundant. So if one goes down, your site can still be fetched from the next closest node. And this is really great, because the closer you can get the bits and bytes of a site to a user, the better the performance and the better the user experience. And that's more difficult to do when you have multiple dedicated servers, all servicing people maybe in Tokyo, San Francisco, Philippines. With this CDN, you can put points of presence in the places that need the most. So the architecture of how CDNs are managed is really fascinating. It's really like a masterwork of distributed computing in which edge servers will regularly fetch and cache your assets from a central origin server. But that's likely not something that you want to think about when you're tweaking your CSS on your site. So luckily for us front-end engineers who want back-end powers, the complexities of CDN hosting can be abstracted behind cloud companies like Netlify. So we'll actually use that service later, and you'll see what I mean. You can really deploy to CDN nowadays with just a few clicks. Cool. So now that we have an understanding of why we might use a CDN, let's follow a request for a complex web page from the browser through the traditional web hosting stack. Let's break this down for just a moment and think about how something gets into the browser. So maybe our browser reaches out to retrieve some resources on a CDN, like what we just looked at. If the response isn't already there, we'll have to get the info from a different server. Maybe it's sitting behind load balancers or something like that. So there's logic on these load balancers which will route the request to one of several other web servers. Those servers may need to make a request to something like a database, maybe, to enrich a template with more data. Like if you're doing a blog, it may have to reach out to a DB to get your blog posts. We then pass that data back to the server and assemble it into the view. We then pass the assembled HTML, CSS, and JS back to the CDN. Maybe we cache it. And then after all those steps, we finally get back into the browser. So this model right here is how millions of sites with dynamic content work all around the globe. So what about JAMStack deployments? What are the steps in a single JAMStack request response cycle? It's a lot shorter and apparently a lot blurrier, I guess. We make a request to a CDN. The CDN has the view ready, and then we're done. So as you see, what's unique in JAMStack deployments isn't just that it uses a CDN. As we just saw, traditional architectures do that as well. What's unique with a JAMStack is that it uses exclusively a CDN without any other backing resources, like a DB or other web servers. That sounds pretty great, right? So why doesn't every site do that if it's simpler? The reason why they don't is because there's a catch, and here's the catch. CDNs are not smart like dedicated servers are. They can only service simple requests for assets. They can't bring in data from other sources like databases as a dedicated web server could. So in a sense, this is what makes CDNs so simple, secure, and fast, and great for hosting your website. But with that constraint on CDN delivery being the case, how could we ever serve an entire dynamic site with complex data requirements from a CDN? So that, my friends, is the core question that the JAMStack ventures to answer. The JAMStack's answer is that the site has to be static, since CDNs only offer static hosting. Static in this context may not quite mean what you think it means, so let's explore that a little bit more. But before we do, were there any questions about CDNs?
Doesn't look like it.
Okay, cool. Very good. Great, so from the definition of JAMStack that we saw a few slides ago, you guys are already 50% of the way there to understanding what the JAMStack is and what makes it unique from other, other architectures. So we're cruising. So I don't know about you all, but when I heard static with the word website in the same sentence, I usually would conjure up images of basic marketing websites, really cheesy 1990s political campaign sites with blinding color schemes, and just generally parked pages with nothing but HTML and CSS. But really, for the sake of this discussion, don't think of static versus dynamic in terms of site behavior. For us, static versus dynamic has nothing to do with DOM manipulation or anything like that. That's not the static that we're talking about. What we're talking about when we say serving a static site from a CDN, we really just mean static assets. And all I mean by that is assets that have everything they need already baked into them. So in our discussion, static simply means a site for which, for its full operations, only requires HTML, CSS, and client-side JavaScript. Stress on client-side for a reason, as we'll see. Therefore, can be served directly from a CDN. So static doesn't mean the page itself never changes. It just means that the asset was pre-built during development. So any questions on static? Cool. So this begs a question you may be thinking of if you've worked in web dev before, which is, how do I build my site statically if I have dynamic data needs? Still haven't explained how the data gets in there. So the answer to that question has to do with rendering. Let's think about rendering as the point at which you inject data into an HTML template. Rendering is when you fill in the blanks of your data needs, whether it's data that's unchanging, like a blog's title, or user-generated, like comments on a blog post. All that data starts somewhere, and it has to end up embedded in HTML if we're going to show it in a browser. So what we're going to do now is explore 3 techniques for rendering. The first is on the server, server-side rendering, or SSR. The second approach we'll see is in the browser, right before your eyes, client-side rendering. And then finally, we'll look at a technique for injecting data into your templates before you even deploy your app, which is pre-rendering. This is the one that I'd say is the most JAMStacky, and we'll actually get to do it later on today. So let's take a look at the process and trade-offs of each approach. Because after we understand how data is injected into HTML templates and JAMStack sites, we'll have everything that we need to build our blog. So let's start with SSR. server-side rendering. This is, I'd say, the oldest and still among the most common techniques for rendering. A template is filled in with data on the server and is delivered as static HTML upon request. The operative word there is definitely upon request, meaning that every time you make a request to say example.com/myblogpost, the server will generate a new HTML page just for that request. So this diagram isn't doing it for you. And ignore CDN there, I actually didn't mean to have that. If this isn't doing it for you, the code might. So this is what would be running on this server here to generate the HTML. There are any number of templating engines available, and you may have used some in your past. And your data sources can come from really absolutely anywhere. Here I have an example using Express.js, which is just a simple server package written in JavaScript. This is a very simple function. The code here simply says, every time you make a GET request to the root, I want you to execute this function and return the result to the client. That's what that code is saying on the server. So what this function does is inject some data into an HTML template, just like we've been talking about with rendering. So notice how this area of code has defined areas in our spot, or defined spots in our template where we're expecting a variable. So the server takes some data, in this case, some local JSON about different drinks that are available, and injects it into that HTML. And once it's done, what you're left with is static HTML that gets returned to the browser. So in SSR, each HTML page you get is rendered on the fly per request on the server. And you as a developer would define the spots in the template where that data belongs. And this template could be anything from a React app to embedded JS like what we have here, or PHP, what have you. The important thing is that the rendering happens on the server, and that's when the data is stitched into our templates. Now let's take a look at client-side rendering. So client-side rendering takes a very different approach from SSR. CSR has become increasingly popular in recent years with what's called single-page applications, aka SPAs. And then SPAs have been greatly popularized by front-end frameworks like React, Angular, and Vue. So the idea with the CSR app is that you click somewhere and you immediately get a new page because the browser doesn't have to ask the server to render a new page for each and every request. With a SPA, only a single index HTML page is sent to the browser, hence the single page part of that name. So in that one file, the core thing that happens is a large payload of JavaScript is loaded and called. The JavaScript then reaches out to the browser to fetch any necessary data from the server. So with CSR, you end up building the whole HTML page iteratively by adding to the DOM on the fly in the browser, which is very different, of course, from getting a full HTML page sent to you from the server directly. It's a little bit like the JavaScript runs document add child for everything you end up seeing on the page, as opposed to getting that full HTML as the response to your request. So back in this slide, you see this arrow here indicating that this entire bundle of HTML and JavaScript is sent down uncompleted into the browser. And then it's up to the browser and the JavaScript to continually update the DOM as things change. The server is doing a lot less work. Cool, so that is CSR. And then the final and probably the simplest rendering approach that we'll look at is what really makes a JAMStack a bit more unique than a simple SPA, single page application. With pre-rendering, your site data is brought into your HTML templates at build time, leaving you with simple static assets to deploy to a CDN. So in this case, you end up also getting just pure HTML sent to the client. And the reason you can do that is because you pre-injected your data as you built your site on your own computer, own machine. Awesome. Any questions on the three rendering approaches that we just covered?
Doesn't look like it.
Okay, cool. So those are the three: SSR, CSR, and pre-rendering. So which of these three rendering methods will we use for our JAMStack blog? I think you may be able to deduce it that we definitely don't use server-side rendering because we couldn't serve it from a CDN, and therefore we wouldn't be able to abide by the two things that make JAMStack, which is CDN deployment and static assets. So do we use client-side rendering or pre-rendering? The answer is we really use both. It uses the two approaches that allow you to send static assets. Because notice again, with this, we just have static HTML. And with this, it's static HTML and static JavaScript, which just has everything it needs baked in. Whereas with this approach, this happens on the server. So JAMStack wouldn't be able to do this on a CDN. That's why JAMStack uses CSR and pre-rendering. Cool. All right, so it's really a hybrid of CSR and pre-rendering. So this, I think, is where the J for JavaScript, A for API, and M for markup really becomes clear. The JAMStack approach is to optimize everything you can through pre-rendering content stored in markup, the M, for example, a blog post or a product listing. If you know it's not going to be changing that often, it makes sense that you would pre-optimize that by injecting it ahead of time. So anything that can't be pre-rendered, maybe something like comments on a blog post, will be client-side rendered and fetched from a remote API after page load, like we saw with spas and CSR apps. Awesome. So as we'll see in Gatsby, a JAMStack site can really be a kind of single-page application, pre-rendered hybrid. And the tools it uses for that are static site generators for pre-rendering. And then for CSR, at least in the case of Gatsby, we use a framework called React to achieve CSR. Awesome. Right, so Aaron Schwartz, the late and great developer prodigy and founder of Reddit, had a really great analogy for server-side rendering versus pre-rendering. He compared rendering your content on the server like frying food for each order. A request comes in, we fry up the data in HTML templates per request, and then we send it back to the browser each time we get a request. In contrast, serving a static site is like baking the HTML and data ahead of time, ready to order as soon as a request comes in. So the moral of the story is this: if you can bake the content of a response before a request even comes in, then you should do so for performance reasons. Right, so that's why CDNs and static sites really pair well together. And JAMStack, when it was created as a concept back in 2014, these practices were already pretty popular. It was just that Netlify saw that trend happening and decided to kind of slap a name on it and build a whole company around it. And since then, the tooling has really kind of flourished. Great. So you now understand the DNA of the JAMStack, which is pre-rendered client-side rendered files served directly and exclusively from a CDN. It's the exclusivity of CDN plus static that makes JAMStack unique, not that it uses JavaScript and APIs as the name might lead you to believe. So here's some other more peripheral aspects of the JAMStack to further your expertise. One is that everything lives in Git. Now this is in contrast to if you ever had a site where you've had to use FTP, file transfer protocol, to send files to a server, and that's how you make things go live. With JAMStack, everything's in Git, so you shouldn't be FTPing directly to anything. Another tenet of JAMStack is atomic deploys. It's a big word to just mean that each deploy you have is a snapshot of the entire site, meaning that if you have that deploy, you can put on a server and it will run perfectly. A third tenet is continuous deployment. And all this means is push code, deploy site. That's all that means. The benefit, this is a benefit that derives from the fact that everything is in Git. This one is another big word for a small concept, instant cache validation. This is because managing CDN cache can be quite difficult. And if you deploy a new site, but your old site is cached on CDNs, then there could be certain CDN endpoints that still have your old site. So another tenet is that you should have a means of instantly invalidating cache on all of your CDN nodes so that when you go live, it goes live for everyone immediately. The last tenet that we'll look at very briefly is instant rollback, meaning that if you deploy something and it breaks or it has something that shouldn't be on there, you're able to instantly roll back to prior deploys. And this is thanks to the fact that you have atomic deploys. So you can just cherry pick one and throw it up there and you're good to go. Cool. So we'll actually get to see all this in practice when we make our Netlify account later on. So some of you may have noticed that this is all an awful lot for an ostensibly front-end centric framework to do. So are you as a front-end engineer suddenly full stack now? I mean, we just talked about everything from static assets all the way back to the hosting. And I think the answer is kind of yes. In relatively few years, the browser has really gone from being just a document viewer to a full-on operating system. So as developers, we start working at higher and higher levels of abstraction, where the stack has really moved up. I mean, just think about JAMStack, Linux, Apache, MySQL, and PHP. This is a stack that went all the way back to the operating system of the server. And I've been developing for 2 years, and I really have yet to do any sysadmin work on a Linux server. And the reason for that is because as of late, the trends of serverless architecture in the API economy has really superpowered the front end. And JAMStack recognized this trend, slapped a name on it, and the tooling really came out around that. So instead of being a back-end horse or a front-end dragon like Chris Collier, we can be this kind of weird full-stack horse dragon chimera thing that we've always wanted to be. Cool. So any developer talk, I think, without weighing the pros and cons is really just preaching dogma. So let's see what you gain and what you lose by using the JAMStack. First and foremost is some of the intricacies of performance that you get with JAMStack. Page load, as we know, is a very key aspect of how a user perceives the quality of your website. In order to measure load time more accurately, the World Wide Web Consortium, W3C, has defined something called the paint timing spec, which states that load is not a single moment in time. There are multiple moments during the load experience that can affect whether a user perceives it as fast or slow. So paint timing answers 3 questions. One is it happening at all? The second is what's in front of the user useful to them? And the third is it usable? Can they interact with it? For the is it happening section of paint timing, this is one measure of that is time to first byte, which is when does the very first byte get from the server to the browser. So because we're using CDN, this can in some cases be 10 times faster than a full trip to an origin server. So that's an easy win there. The second thing that we look at is first contentful paint, like you see here. And the first contentful paint, that's the time when the browser renders the first bit of content from the DOM. It may not be useful. It could just be a button with no text on it, but it's rendered something. So that is a contentful paint. The second thing is it useful to anyone? And this measures the time from navigating to a page to the time when the user feels that the primary content of the page is visible. So for Facebook, for example, you may load the page and you have the top bar available. That would be a contentful paint. But once you get the first newsfeed item, that's now the first meaningful paint because there's something for you to consume while you're on the site. And then finally, is it usable? Is time to interactive, which measures how long it takes a page to become interactive. So let's think. With SSR, first contentful paint, the first time anything is rendered in the DOM, and the first meaningful paint are likely to be pretty close since we're returning an entire HTML page in one go. In the case of Facebook, for example, you would have the top bar at the same time you would have some newsfeed items because all that was sent to you from the server directly. With pre-rendering and CSR, first contentful paint and first meaningful paint can have a real chasm between them. And you as a UX designer can really play that gap to your advantage. For example, you could provide interesting pre-rendered content to improve the first contentful paint, or the first meaningful paint rather. So give the user at least something pre-rendered in the app, like an app shell, that at least gets filled in later during the first meaningful paint. This is actually what many spas do. If you load Facebook right now on your computer, I would do it, but I don't want to unshare the screen. You'll notice that a lot of sites will have an app shell that later gets filled in. The app shell is the first contentful paint, and what comes after is the first meaningful paint. And when you have the ability to pre-render like you do with JAMStack, you can really fine-tune what that app shell is like. So that's performance and some of the fine details of how JAMStack can optimize between first contentful and first meaningful paint. Scaling is an easy win. Like I mentioned, because it's on CDN, you basically get infinite scaling with no need to provision new servers. CDNs are cheaper than dedicated web servers, so it'll cost you less to scale. And you get global reach out of the box without having to configure any service zones or anything like that. Security. So compared to traditional web hosting, the JAMStack approach exposes a lot fewer vectors for attack. Traditional server-side and CMS applications like WordPress expose a lot of APIs and services that allow administrators to manage data and content. One of the biggest hacks that people look for is just /wp-admin hacks. There's been so many attacks on that, and that's because of the admin APIs exposed by those CMSs. Whereas with JAMStack, all you have is delivery of assets to the browser that consist entirely of read-only static files served directly from CDN. So compared to all of the different opportunities for attack here, maybe someone gets in your web server, in your app server, the DB server, there's a lot of points going on, and every time data leaves one device and goes to another, that's a vector for attack. So with JAMStack, it's only a single vector. The main vulnerability that you could be exposed to is using certain APIs on your site that reach out to a third party. So just be sure that if you are using any third-party APIs to audit them for security ahead of time. Search engine optimization. This is one place the JAMStack and single page apps in general are definitely beat by server-side rendered pages. Think about it, with the CSR approach, the final content of a page is created in the browser. And the problem with that is that search engine crawlers don't necessarily wait for the JS on a page to finish rendering before determining what the page is all about. So a good question to ask yourself when building your site is this content SEO critical? And if it is, you may want to pre-render it, because the web crawlers go by pretty fast. If you send something out, it may not wait for that newsfeed post to actually show to determine that that is relevant to the search, something like that. So there's plenty of SEO tips and tricks to mitigate this unfortunate SEO con of JAMStack, far more than I would want to outline here. But I'll link to them in the resource section to see if you can maybe, with your team, get around this, this downside of JAMStack. Cool. I think I saw one question. Let's see, I'll open chat. Cool. Never mind. You guys are great. All right, very cool. So let's build that blog that I promised. I've made the horrible mistake of promising a live demo of Gatsby and Netlify, so let's deliver on that now and just hope that the demo gods are on my side. So we're gonna be using two tools. One is Gatsby.js, which is a Node.js-based static site generator. We're gonna use this to pre-render parts of our website. The second thing we'll use is Netlify, which as mentioned before, is a cloud service offering CDN hosting and Git-based continuous integration, continuous deployment workflows. AKA, you can deploy your site from GitHub. Well, you can host it on GitHub and deploy by simply pushing code to GitHub. I mean, to Netlify. We'll see. Awesome. So what is a static site generator? Answer is simply what we use to pre-render a website. So a static site generator finds your site's data, whether it's local markdown or content hosted on some other services like a content management system. It then takes that data and it compiles it into templates on your machine, like we saw earlier. And what it does is spit out static HTML, which is ready to be deployed, or static HTML as well as JavaScript and everything else that we looked at earlier. And that's really it. What you end up with is just a bundle of HTML, CSS, and JS that you can send right to a CDN. So there are two reasons why pre-rendering with an SSG like Gatsby is really cool compared to deploying just a regular old, say, React app. And one is that Markdown is a very non-developer friendly language. So using Markdown, you can separate content from template and have non-technical maintainers adding content who don't know how to code at all, but it can be pulled in by a static site generator. And the second is that pre-rendered content is immediately available for the user to see. So there are many other static site generators besides just Gatsby. I think the JavaScript's a pretty commonly used language, and it's one of the best ones that I found for it. So I'll link to other SSGs and resources, but we're going to use Gatsby for this. So what you're going to need for this is Node.js running on your machine, the Gatsby command line interface, which we'll download together, a Netlify account, and a GitHub account. Cool. So with that, we're going to leave Google Slides and go instead into VS Code. I don't have to sign in, or do I? Yes, I do. Later on. All right, little transition here. Cool. So as I said, the first thing that you're going to want to do is install Node. I already have it installed here. What Node.js is, it's a JavaScript runtime that can run on servers and on your machine. Prior to Node, the only runtime for JavaScript was the browser. So what Node.js did was really set JavaScript free to run on other platforms like servers as well. You can download it at this URL, which I will put in the chat now, if you haven't got it yet. Step 2 is installing Gatsby. So if you already have Node installed, you'll have something called Node Package Manager, NPM. And you can use this to install a bunch of really useful packages on your machine. So the command to install Gatsby to your global packages, and making it global will mean that you can run the Gatsby commands from anywhere on your system, is simply npm install-g Gatsby. And I'll copy that as well. I already have it installed here. Here are my versions. I'm not going to install it again just for the sake of time. but we're running 274 of Gatsby CLI. The next thing you're going to want to do to save a lot of time is cloning this starter blog. So this is simply a blog provided by Gatsby, which has a lot of the main content for a pretty basic Gatsby blog that I've seen all over the place. So that's what we're going to work off of today. One sec. Sorry about that. Cool. So I already have it cloned here. If you haven't cloned it yet, what you can do on this is simply go to clone, click that to get the link to it, and then do git clone and get it onto your machine. That'll take it down from GitHub for you. Awesome. So after you've cloned it, this is a terminal down here within VS Code. After you've cloned it, you're going to want to run npm install. This will take in all the dependencies that Gatsby has and put them into the project for you. I'll copy that command as well into the chat. So I already have the Gatsby CLI. Let's see what it makes available to us. Just running it here in this project. Exposes several commands. The only ones that we're going to use today are Gatsby develop and Gatsby build. So the develop command boots up a local web server, and it listens for changes that you make in your site so they can be reflected immediately on your website. So let's run Gatsby develop to see what we have here. What did we just clone down? So we're running Gatsby develop, and it looks like it's running on localhost 8000. Awesome. So this is our blog. This is a basic Gatsby blog from Kyle Matthews, who is the guy who invented Gatsby. Click around, you just have some basic articles, some good formatting. That's what we got. So let's look into the code behind this blog. And as I mentioned, JAMStack's good for a lot more than just blogs, but I think that this will illuminate the workflow of JAMStack quite well. So like every node project, Gatsby has a package JSON, which is the manifest file defining all the different dependencies that you need. Most important of which, of course, is Gatsby itself and React. So as I mentioned, Gatsby uses React for two things. One is componentization, and the other is being able to CSR, what you end up sending back to the browser. So what is React? It's simply a front-end framework for syncing state with UI and splitting your UI into reusable components. So here's the real heart of Gatsby. Let's get right into it. You see, the only thing unique in this file hierarchy is that we have these config files here. And this file, Gatsby node.js, is really the heart of where we're going to pre-render our entire site. We finally made it after all that. This is where it is. This is where the pre-rendering process is kicked off. So let's break it down method by method just to see what it's doing. First off, we have export create pages. So for those of you familiar with how packages work in JavaScript, you see that you're exporting some methods here. And the names are very important in this case. So notice that if I were to import this somewhere else, if I were to import this like this, then I could simply call it like a method. And that's actually what Gatsby does during the build process, is it creates the pages. So what it's doing there is just calling that. So that's why you have to export it from this file. This is where Gatsby will be looking to create the pages. When Gatsby does call create pages, it will hand it some useful things for us to use. Things like GraphQL and actions. Let's take a look at GraphQL to start. So what is GraphQL? For our purposes today, since we've already covered a lot, just think of GraphQL as a query language for getting data from somewhere. It's a standard defining how a user can ask web services for data. So before you can pre-render a page, you of course need to locate and return data to inject it into the template. So in our use case, we want to fetch some information about blog posts. And Gatsby uses GraphQL to fetch data from your site during the build. That's nothing new for fetching remote data, but the interesting design decision that Gatsby made is that it even uses GraphQL to fetch local data. In other words, it schematizes your markup using a plugin called Remark and makes it queryable using GraphQL. So let me show you what I mean with the help of a console called Graphical. Cool. So with every Gatsby site, you get this for free. You get a graphical console. One sec. If you ever used Swagger before, then Swagger is to REST what Graphical is to GraphQL. It's simply a console where we can run queries and get back results. So in this case, we're actually running queries against our Gatsby site itself. Start with this one. So in this case, you can simply run a query on the left side, and it'll give you the results from Gatsby on the right side. So in this case, the returns are blog posts, different titles of all the blog posts that we saw. So that's pretty cool, but where to get them from? This is kind of a black box, right? And how does this GraphQL query know where to look in our file system to get this data? How does it get all the way from our markdown files into what we see before us here? So let's return to the code to find out. So we're trying to answer the question of how did it find that data just from this query? It all starts as well in Gatsby config.js. So this is where site configuration options and all plugins are added. So the two most important plugins that you'll see in many Gatsby sites are Gatsby source file system, and the second one is Gatsby transform remark. We'll explain what those are right now. So Gatsby source file system, what it does is source data into your Gatsby application from your local file system. This plugin creates file nodes, if you're familiar with GraphQL, and the various transformer plugins like Remark take that data, those file nodes, and can render them into whatever they want, really. So let's go back to Graphical and try to see what these file nodes look like. So we're sending the source file system plugin to our blog and to our assets, and it's coming back with the data. So this is a query that you can run to kind of see all the different files that exist on your system. So in this case, it found 6 files in total when we ran that. This is because we have the plugin Gatsby source file system, and GraphQL is just built in to Gatsby. So the different things that it found were some markdown files and some JPEGs. So we have metadata about our site's assets themselves. So why do this? Why was this a good idea in terms of engineering? Or was it some kind of useless abstraction or engineering overkill to schematize your entire file system like this? So the reason that Gatsby schematizes your site's file system is because setting standards opens up the floodgates of open source plugin developers to run wild. Similar to WordPress plugins, the richest part of Gatsby sites are definitely the plugins. And those are made possible by Gatsby source file system, since plugin creators can rely on a common interface for getting files. They know that if they query like this, they're going to get back all the things that the user is exposed to them. So one such plugin that takes advantage of this standard way to look at your files is Gatsby transform remark. So this plugin looks for all files with the MD extensions, like the ones that we found here. And it takes the content of those extensions and it parses them using another node tool called remark, hence the remark in the transformer thing. What it does after that is it makes the data contained in that markdown available as a second layer in your GraphQL data graph. So that is how Gatsby chooses to achieve the M of the JAMStack, which is pre-rendered markup. So that's a lot to take in, and it's one of the most unique things about Gatsby is how it turns your whole site into a data graph. If you can really wrap your head around that, this is the lowest level that you'll really have to get. It's just the fact that your entire file system is accessible by plugins. And that opens up the floodgates for things like JPEG optimizers, things like Markdown transformers, JSON transformers. You can plug into that system now that it's been standardized by Gatsby. So we really reached the hump here. You just got over kind of the hardest thing to take in about Gatsby, somewhat downhill from here. Let's go back to Gatsby node to continue looking at where we're going and how we're going to get this data that comes back to finally appear in front of us on our website. How does it get all the way up to be visible here? Cool. So we saw that we can run this query here that because of Gatsby transformer remark the thing that we found here, it finds all of our markdown files, which are simply located up here in content. It found those. This is just me writing a blog post or someone in my organization writing a post. Gatsby allows us to access that with this query. So for those of you familiar with JavaScript, this await keyword simply means don't continue execution until GraphQL has returned the markdown that I want to see from this. So once we have that result and we have the posts, all we do, these posts are all of the edges. Let me run that query one more time, so we can see exactly what post is. So within posts, each edge, which is what's returned from it, will contain nodes that have different information. In this case, we have title. Maybe we want the date as well of the post. Maybe we want an excerpt from the post. You can see this is a really hyper-powered query. And the important thing is that you can even get the full HTML parsed by remark available to you just from this one query. So as we saw over there, we have let posts is equal to this. What post is going to be equal to is this giant JSON that was just returned because of Gatsby transformer remark. Cool. So that's what this result is going to be. So all we do then is we rip off all the stuff that I just showed you into posts. And then for each node, for each blog post that we were able to find, we run this function down here. We loop over all the posts. We create one page for each post by calling create page. Where did create page come from? It came from the second thing that Gatsby calls create pages with, which is this actions thing. The most common one you'll use is create page, more than likely. So for this post, what we're passing to it, as I mentioned, is just one node of this. So in this case, it would just be new beginnings, that whole post. So what we mentioned earlier with pre-rendering, how you inject data into a template on your machine, this is where it happens, is exactly right here. We take a component, this is our template. They call it a component because they use React, but really this is the template that you're injecting it into. We create a page by giving it that post. So let's take a look at that template. It's in the components folder. This came standard with Gatsby. Oh, no, I'm sorry, it's in the templates folder, my bad. So this is a blog post template. We can see here that we have post available from this query. So slight correction is that it doesn't pass it directly to blog post. It takes a secondary query within blog post to actually get it into there. But once it is in here, you're able to use that post to populate all the different fields, like title, excerpt, and all the HTML right here. So this is where the real meat of the blog post finally gets in there. So that's the full cycle of pre-rendering. It all starts in Gatsby Node. And during the build, we can see that we are sourcing and transforming all the nodes like we talked about. That's all thanks to the plugin architecture of Gatsby. So the one other folder in here is called pages. And components that you put under pages become pages automatically with paths in their name. So I wanted to create a new one here. I already have a new page, so I guess newer page.js. All you put in here is just simple React components. And without having to use React Router or anything like that, I can save that and immediately go back to the site. And this should be available to me. Great. So anyone who's ever done a spa and had to deal with kind of like different routing and everything, this is just kind of not a core feature of Gatsby, but it's pretty cool that if you need a new page in your site, all you have to do is add a React component here and you immediately have it. So it's kind of like an auxiliary benefit. So that's really the basis of all of Gatsby and static site generators in general. We've seen how markup goes from markdown files, gets sourced into our site's data graph by the Gatsby source file system plugin, gets transformed into accessible data using another transformer plugin, and then finally consumed by a template called blog post. So some of you may be thinking, but what if my data is remote? What if it lives in a content management system or elsewhere in the project? And there's a simple answer to that, and it's simply change the query. So in this case, we're getting it locally. but this can be anything you want. I mean, if you need to fetch from a CMS, you can do it here. So this is the point where the A of JAMStack really kind of comes into play, is that you're only limited by your imagination and what data you bring in using Gatsby Node.js. Awesome. So I see a question here. Can Andrew comment on JAMStack? Backend that uses serverless APIs. I'll cover that in the end. I'm going to return to that if that's okay. We're about to get into the Netlify section here, so that may clarify things a little bit as well. Cool. All right. So really quick, let's commit our changes before we deploy to Netlify. I'm just going to add that newer page that I gave. Push that up. Okay. Let's go to Netlify. Not Netflix. Always do that. Very cool. So this is Netlify. This is the main dashboard that you see. And these are all the different projects that I have. So deploying to a CDN on Netlify is quite easy. You simply do new site from Git, connect to your GitHub, was authorized. You choose the repo that you want it to link to. In this case, this starter blog thing that we just pulled down and I just pushed to the remote. So the only thing that you need to configure for deploying to Netlify is your build command and what directory you want to publish. They have a pretty generous free tier. So I'm going to deploy a new site right now. The most important thing that we saw there was the build command. So Netlify is kind enough to recognize that that is a Gatsby project, so it suggests the correct build command. So while that deploys, let's take a look locally at what Netlify is doing remotely. So I run Gatsby build here. Or actually before that, oh, it looks like we had an error. Let me even, you could even remove public. Running Gatsby build locally. We have to do some live debugging. That makes sense because I put that there. Cool. One more try. All right, so as mentioned, you get really good visibility into the build steps of your site. So we can pretty clearly see what it's doing. It's creating the schema like I mentioned, and it's sourcing all of your files, builds up the schema, it calls create pages. So all of this that you see here, the same thing's gonna happen on the Netlify server. So after it runs everything, it builds the production JS and CSS bundles and ends up putting it in this public folder. So this is kind of the grand reveal of what pre-rendering looks like. So remember blog posts that used to be Markdown and they were injected into a template, they're now static HTML. And this is what eventually is going to be actually served from the CDN. So that's what Netlify just ran for us. This is the real end of the road here. Oh no. Well, such is life with live demos, but maybe this can be a learning experience. Let's see what it logged. Not quite sure why that didn't deploy. So instead, let's go to one of my other well-deployed sites instead. So I can show you what it looks like when you are right there. I think it might be because I deployed it twice. Oh, I think that someone in the comments just had a great idea, which is to push again after that local change. Thank you to Jonathan Ho. So it's actually a good opportunity to show you what I mean when I say continuous deployment via GitHub. Without going back into the Netlify console right now, without going back to the site, if we go back there now, the site that is linked to this will now be deploying. And the reason why is because GitHub webhooks will notify Netlify that I push new code. So without having to leave VS Code, I can be pushing to my website. So if I add a new blog post, all I have to do is git add, git commit, and git push, and I'll get a new site. Let's go back and see if that worked. I think this was the one. It's probably building. Cool. So we see that site deploy is in progress. That's a different thing. So I find that it usually takes between 1 to 2 minutes to actually get up there. So I'll use that time actually. I see Karen ask, can Andrew comment on JAMStack and backend that uses serverless APIs? Advantage and disadvantage example where this combination is recommended. Okay, good question, Karen. So I'm actually going to show you that right now while this is building. Why not? So the question was, what is an example of a JAMStack site using a serverless API? How could I use a serverless API within just the code that we have here to the left? Let's take a look. So let's say that I wanted to do something like fetching the weather. There's a great serverless API, or I don't know if it's serverless necessarily, but to be honest, as far as the client's concerned, it doesn't really matter if you're hitting a serverless API or a containerized API. It's just a REST call in the end. So in this case, we're going to be hitting an API, and I'll show you what the A of JAMStack really looks like. Don't be disturbed if you're not familiar with React. There are so many good tutorials on it. What this page is going to do, this /new page, because I put it in my pages folder, all it's going to do is when it renders, it's going to make a request to the Open Weather API. So Karen, this would be an example of some kind of, maybe it's serverless. I don't really know. I don't have to know. What it's going to do is when this runs, it will fetch data about Detroit weather. And then it will set the city to Detroit, whatever comes back in the JSON. And it will set the weather to what we get back and then display it. So let's just run that locally. Let's see what that looks like. So what we have here is the A of the JAMStack. It's not unique. It's just simply reaching out to a some API somewhere. Okay, great. So that did deploy. So thank you, Jonathan, for noticing that. So if all went well, great. So I'm going to put this in there, and you guys can see that we actually just deployed simply by pushing to Git without having to FTP or anything. So you guys should be able to see that now if you want to go there. So instead of showing you, here we go, let's complete that. The API question, I think it was called new page. Boom. So look what just happened there in a split second. For a little while there, before we fetched the actual data from that Open Weather API, we had no city, no weather. It fetches it and returns it. So this is what client-side rendering looks like. Getting back to that discussion we had about SSR versus CSR, if this was SSR, you wouldn't have that little lag, right? You wouldn't have that little no city. But because we're reaching out to the API from the browser, that's why we have that little bit of lag. And you can do whatever you want there as a UX designer. You could have a loading spinner, whatever you want. You really control it. Cool. Yes, that's how you deploy for the first time. The first time you deploy to Netlify, you're going to have to go in here and go through the new site from Git process. But once you've associated it to your GitHub repo, all you have to do is push code to a branch which you defined. In this case, I just have master branch for all of them. So we talked earlier about instant rollback. Within Netlify, you can roll back to any previous commit. Let's go to one that didn't fail. I had a lot failing the other day. Also a bad example. This one's probably good. Sure. So if I wanted to go back to what I launched at 7:48 a.m., with Netlify, it's as easy as publish deploy. So that's how you get instant rollback. You mentioned atomic deploys. The reason you can do this is because the entire site is just contained in whatever that deploy was. There's no, separate database that we reached out to, anything like that. It's just all there for you. So you can retry deploys, set the settings, whatever you have to do. Cool. So we've really made that full process all the way from thinking that JAMStack is just about JavaScript and APIs, when really that's the whole internet, to realizing that it's truly about CDNs and having everything in static format. So that, my friends, really is the JAMStack. It's quite similar to single page apps that have become the bread and butter of front-end development, only it requires deployment of all static assets from CDN and encourages you to pre-render your content as much as possible. Yeah, a lot of people see it and they say, well, isn't that just React in a different form? And the answer is yes, but once you have that kind of build process that Gatsby gives you, it opens up the floodgates for thinking about like, hey, maybe I don't have to fetch that from an API. Maybe that data only changes once a day. So what if I could pre-render that data so that the users can benefit from the first meaningful paint a lot faster than it would otherwise? Having this kind of access to the build is what really differentiates static site generators from a plain old npm run build on a React app. So once you kind of open up that place for good behavior and optimizations, you can oftentimes start rethinking your stack and when you can be rendering things, when you have access to pre-rendering. Awesome. I think we've really made it. So I'm going to open everything up for discussion now.